Another click. I think I found a bug. I've got a Siglent box right here. Let's open it up, see what I've got. Now if you watched the mailbag video 2 days ago, you already know what this is. Well done. If you don't watch my mailbag videos, maybe you should start doing that, because then you'd be in the know. So I'm going to review this oscilloscope. This is not on the market yet, it'll be on the market very soon. It's brand new, SDS814X HD. Quick start guide thing as you always get, and a little calibration information thing. This has been loaned to me by Rob at tailtech.co.nz. You can see that there. I'm not keeping this, this is purely on loan for me to review. This is going to be going back. So I'm benefiting from this in no way whatsoever. To be clear, I don't have to make a declaration. So, USB cable, standard B to A, power cable. Now we also have some accessories in this one. So we have the SLA1016. These are options for this unit. You can actually get these things with these options included. So SLA1016, and as I showed in the mailbag, it's this logic analyzer here. 16 channel logic analyzer, uses the S-bus. It's basically an HDMI cable. There's the probe assembly here, which goes on the end of the cable, which is tucked in here. And you've got some grabbers in there as well. So that's the logic analyzer. So we do 16 channel logic analyzer on it. We also have the arbitrary function generator, waveform generator thing, which is the SAG1021I. Interestingly, it's an I. So it's 25 megahertz, 125 megasamples a second. And it's got two BNC ports here, aux in and out, and the actual output. And there's some LEDs on the end there. And obviously USB port this side. This is USB powered, and it communicates with the scope, and the scope controls it. So in here we have USB cable as well, and probably BNC cable. Yep, there's the scope. And it also has 4 probes. These are the PP510. It's a 4-channel scope, so it's got 4 sets of probes. So it's gone to the black. It's sort of black actually. This isn't actually black, it's more of a dark grey. I don't know, I'm not sure. I'm not set on the black up. I actually quite like the lighter coloured faces. I don't know, I'm not sure about the black thing. I'm not sold on that. I mean, I know it's the current trend, but yeah, I don't know. There she is. There you go, and that's what it looks like. SDS814X HD. So this is the 100 MHz version. It's got 2 gigasamples per second, 12-bit. This is the main thing here. It's a 12-bit scope. Nice. Which is why it's HD. HD is referencing the 12 bits. And obviously here's the S-bus port here, USB port, calibration port there for the probes, as normal. 4 channels, as we discussed. Vertical, horizontal, it's shared. Choose the ones there. Digital button just there. Standard format. Let's look at the back. It's supposed to be 80 watts max. Well, okay. USB ports, LAN port. Pass fail output, no trigger input. Right, so it's trigger out. No trigger input, which is interesting. I've never ever used a trigger input. I mean, there's probably times where I could have done it and made it a bit easier for myself, but I've always just used one of the channels. Yeah. Coming 70, 100 and 200 megahertz versions. Like I said, it's got the logic analyzer and the waveform generator, which are options. They don't have 50 ohm input. It's only 1 mega ohm input, 70 picofarad input. 1 mega ohm only, there's no 50 ohm switching on these. Some scopes have got 50 ohm switching. This isn't one, so if you need to do 50 ohm measurements, you're going to need to put a external load on this thing, a 50 ohm through terminator on each port you're going to be using it on. I prefer to have 50 ohm switching, but obviously in this kind of price bracket of these things and this range, things are minimised to keep the cost down, and not everyone uses that feature. Some people only ever use probes with their scopes, so they don't need the 50 ohm switching. Just use a 3 terminator. It's not as good, you know, you do still get some ringing between the terminator and the scope and things like that, so it's not perfect, so you do still get some artifacts there. It's a small compromise. One of my other scopes doesn't have 50 ohms on it, same sort of deal. I tend to use 3 terminators anyway, because I don't like to risk potentially damaging a 50 ohm load built into the scope. I'd rather use an external one, which is high current. For example, you know, I'd get one like this. Right, I put this on it. One is 50 ohm, I'll stick that on. That'd be on there, I'll use that instead. This is much more robust than the ones that are into the scope. This is a 5-watt terminator. I'd rather use something like that than the little tiny resistor that's inside these scopes. I mean, they can handle a bit. User interface apparently is very much like my SDS814X Plus on the shelf up here. A lot of these user interfaces in the Siglent units are very similar anyway. They do share a lot of features, and they do tend to propagate firmware changes across the models to a point. As long as the model's not too old, I'll propagate across, but you know, basically if you use one Siglent scope, you can use all of them really. That's enough waffle. Let's power this thing up. Also, one of the things to consider, this is 2 gig samples per second, and that's 100 megahertz scope, which gives it a bit of headroom there. For example, my 2000X Plus scope, which is considerably more expensive than this thing, that's also 2 gig samples per second. So actually, the sample rate on this is actually quite impressive. So 2 gig samples per second is obviously shared across the 4 channels, but usually you have a pair. So this is shared, this is shared. So if you're using channel 1, channel 3, you'll probably get 1 gig sample per second on each of those channels. But if you use 1 and 2, you'll get 500 megasamples per second because they're sharing that 1 gigasample. When you're using multi-channel scopes like this, you may need to consider that aspect of how you're actually utilising the hardware. But generally you don't think about it, but sometimes it does matter. Right, let's power this thing up. I'm still waffling. Let's turn the power on. So standby power is about 4.4 watts or so. 4.5 maybe, call it 4.5 watts. Power factor is 0.5. Alright, so that's standby power. Let's turn it on, see how long it takes to boot up. I will probably skip through, but I shall time it. Yeah, you call it 31 watts during boot up. So that's 30 seconds, 35 seconds. We'll call it 35 seconds. Not too bad. And we're sitting at 31 watts. Power factor is 0.62 according to that. Let's turn some more channels on. Channel 2, Channel 3, Channel 4. Still 31 watts. Digital channels. Device not detected. Right, so we need to plug that in before we can turn those on. Also, we've got touch screen as well. If you want to do stuff on the screen, we can do that. Now, this screen resolution, although it's a 7-inch screen, it's got the same resolution as a bigger screen. What that means is it's actually a finer detail. So it's actually got the same amount of information on the screen. It's just a bit smaller, which means, you know, although it's a small screen, the resolution is really fine detail, which means you should be able to see it really well. Now, what I want to do though is obviously we need to be able to see what we're doing on video here. So display intensity. So we've got 2 ways to do intensity. We can do it for this knob here. Now it's selected it, or we can tap it again and put in what we want. 100. Enter. Just to make sure it's nice and bright for video as much as possible. Now this actually is a scroll menu. Greticle, we also need to bring this up. Now we do it this way. You can see the greticle coming up now. So I'm going to turn it up to 100% as well for now. Right, so LCD brightness, intensity and greticle all 100%. Right, let's go through the menus, look at all the different options this has got in each of the menu functions. We may or may not dig into each individual one. I have covered a lot of this stuff in previous review videos where I've done other Siglent scopes where the menu system is basically the same. This does have some extra options in it, so I know there are some differences. There's a lot of stuff in here which I've already covered in previous reviews. We'll see how we go with that, I suppose. Suppose we should have a look at the probes, shouldn't we? It's channel 1 probe. There's some information about it there. 100 megahertz probe. 10 times is 13 to 17 picofarad. Like a multiplier of times 1 or times 10. Now usually if you want best performance on a scope you want to use times 10 anyway. Times 1 can be useful, but it loads the input down and your circuit under test and actually greatly limits the bandwidth. So you don't want to use that unless you really have to. The higher the voltage, the lower the frequency you can use. If you're measuring a higher frequency, your voltage derating because it's to do with the energy in the waveform. Standard accessory kit, little spring clip and... So the probes don't have any kind of auto sensing on them at all. There's no kind of automatic probe detection there. It's purely manual, so if you want to change the times 1 times 10, do it on the probe like you would do normally, and you have to set the scope to make sure you've got the correct setting here, like here's 10 times. Right, there's no auto sensing on those. Some scopes have got it, a lot of my other scopes have got auto sensing. This one, being a lower cost scope, doesn't have it. I should also talk about price of these things. Now I do know what the price of these is supposed to be. I can't tell you yet because it's not available yet. Let's just say it's going to be very competitively priced. It's definitely going to be well worth a look when these things are released to the market. Well worth a look. Based on price alone, obviously I don't know about the feature set yet, I haven't played with it yet myself, you've seen as much as I have. But the price looks good from what I've heard. So we should do a scope probe conversation just to make sure that's all good. Stick that on there. Get it on there just for the completeness. There's the waveform triggering. It's already pretty good there. I'm guessing Rob's already given us a tweak when he first got them, because that's the same Rob likes to do when he gets his gear. Before he passes it on or sells it to someone, he gives it a check over, make sure it's all working correctly, make sure things like this are tuned and it's got latest firmware, that sort of stuff. It doesn't surprise me that this thing's basically ready to go when I go to look at it. If we look up here, we're getting 99.9029 megahertz. Don't know if you can see it on the camera here, I'm a bit zoomed out slightly. Let's look at some measurements. Measure. Got some default measurements here popped up already straight away. So if you look at the frequency based on the waveform, so this is saying 99.903 or so, and that's saying the same basically. So based off waveform, based off that, very similar. We'll look at this in more detail, chuck it on IF source and check that sort of stuff as well. get really close on the screen, we'll look at the menu system, and then we'll look at some functions, and we'll try playing with some things and do some testing. Now I believe this scope, like the other Siglent scopes, supports USB based mice and keyboards. So if you want to plug a USB keyboard in to make use of the user interface remotely, in this case I'm just going to use touchscreen because it's right in front of me and it's easy for me right now. But I could use a mouse and just plug a little dongle in and use a mouse. Now this does only have 2 USB ports, one here on the front and one on the back, as I showed you before. So if you actually want to use multiple things like a Wi-Fi dongle, then you might find you're running out of ports, because you need a port for if you're going to use a flash drive to store data on. If you want to store sample data or take screen grabs or whatever you want to do, you can store those on a flash drive. So that's one port gone. If you want to use your signal generator here, the AWG, there's another port gone. If you want to use Wi-Fi instead of Ethernet, that's another port gone, but you've only got 2 ports, so you actually need 3. Minimum, really, you need 3 ports. So you're going to use one of these things with a wireless network connection, you probably want to use a little USB hub. Now I did show one in my last mailbag and one before that, something like that. Anyway, recently, within the past couple of mailbags, I've shown some little USB hubs which will plug directly into this port on the front here and not take up too much room. They'll sit there quite nicely, or even on the back, and that will work alright. Tested them on my other Siglent gear and they work fine, so they're actually quite good for that. So you can plug up to 3 devices into one port. Menu system, keep getting distracted and waffling. Utility, so menu, system info, what we're getting here, software version 1.131, U-boot 2.8.10.10, FPGA 2023-1229, hardware version 0, interestingly, and obviously here's the MAC address stuff down here as well, USB ID for things like LabVIEW and stuff like that you can use for it. So that's that bit. System settings, got languages, reference position, got horizontal and vertical reference. What these are is when you're zooming in and out, or the reference point is set, I should say. So horizontal reference is position. So if I move this position over here, you see the little blue triangle moving, and I zoom in and out, that stays the same if he moves around it. Okay? By changing the time base. If I change this to delay, like that, I move it over here again to the right. As I zoom in and out, you see that is shifting off. So what happens is your waveform will stay in the same place, but this starting waveform will stay in place and it will shift off that way. Depending on what you're doing, you may want one way or the other. Vertical is the same deal. Alright, so right now it's on position. So if I bring this down a bit down here, and we'll change this, it will scale around that point there, that reference point. Now if I go to offset instead, and I change it, this will also shift. Exactly the same way the horizontal did. So depending on what you're doing, you may prefer one way or the other for that function. It's a really handy thing to know it's there, because sometimes if you're doing like digital decoding for example, you may want it to be on a certain point on the screen and you want to zoom in to see it better, and you can't because it shifts off, and then you have to recenter it and it shifts off and you recenter it. It can be annoying. So if you know how to use that particular function, you can get it to zoom in just on the bit you've got on the screen right where you want it. Touch screen on and off, beeper on and off, I like beepers. Auto power on is disabled, like you turn the power off and when you turn the power back on again, reapply power, it will automatically boot up. I get way too many power outages here, I don't want to come back and find all my gears turn itself on. It's got a screensaver, so you can set a time here, so date time options. So it has an NTP server as well, NTP access, and it has an NTP server which is based on IP address. Right, so it's based on IP. I'm not sure if it's got an ITC in it or not. IP address, that's interesting because a lot of NTP servers are based on domain name, not IP address. I mean, obviously you can find them out. Whenever you look for an NTP server, it's always listed as a domain name. I think ours is like nz.pool. Something or other. I can't remember now, I can't remember what the address is, but something like that. So the fact it's got an IP address here instead is, to me, a bit limiting. Having a domain name would be better. Anyway, we also do manual time as well. So, I/O options, it's got a GPIB address, obviously based on Ethernet adapters and stuff like that. Software options, this one has got a frequency generator, logic analyzer and power analysis options enabled. I'm not sure what options there are for these, that might be it. I mean, there's nothing else saying temporary or trial or anything like that, so that might be all the options that are currently available for this. Maintenance, self-cal, upgrades, developer options, I believe that needs a password. It does self-test. Quick cal is off, but it does is like a periodic readjustment, to allow for temperature changes and things like that. And sometimes you want it to do that if you want really precise measurements, and or as precise as you can get of a oscilloscope. It can be handy, but it can also be interruption if you're trying to do sampling. It may affect what you're doing, and you don't actually want it to do that. You can always do manual self-calibrations if you want. Service. web server. So this has got a web server built in, so you can connect to your network and actually connect to it remotely from a computer and view the screen and control the oscilloscope from a web browser. Works quite nicely. I've done that many times in my live streams. You have LXI information here. I've never used LXI, not to my knowledge anyway. SMB file share. So client and server. That's interesting. So I'm guessing that means you can potentially share screen grabs across the network, something like that. I'm not familiar with this part myself yet. And that's that menu. There's a lot in here. Obviously you've got save and recall, save button, quick action, wave gen options, help. These things usually have quite good help in them, so you can go to help in a certain screen, it will tell you about it. Print, reboot and shut down. If you're remotely accessing this thing and you can't reach the button, you can just go to the menu and tell it to shut down. You can do that from remote access in a browser. Save and recall. You can do saves of different types. You can do setups, references, images from screen grabs, CSV files, and things like that. To default key and file converter tool, I'm not quite sure what that one is, I haven't played with that either. And recall, apparently do a security array is completed, so you can completely wipe it in a safe way. What it actually does, it starts like a wipe, so it starts again from scratch. So there's no data on it, or any files you may have saved to it, such as screen grabs and stuff like that, will get wiped. So if you want to record a setup and stuff like that, you can go to File Manager, and if you've saved a setup in here for a certain configuration you use, you might use this for different functions, and so you want to have different configuration. You might have one for doing digital channels, you might have one for doing 4 channels or 1 channel, and there's certain repeated tasks you use it for. Then you may want to save a setup and actually just then load that next time you want to do that particular task. You've got references as well, reference waveforms, things like that, you can do those too. Save button, this tells you what to do when you push the save button. You can do a screenshot or save to. So if a screenshot was to take a picture, store it in a default position. Save to allows you to choose where it goes to, so you can choose what you actually do with that, where it places it and that sort of stuff too. Quick action button, enable, disable. You can choose functions for that. Triggering and things like that, display options, depends what you want to do with it. Wave gen, well, I've got the wave gen plugged in, so you can probably see something with that now. We'll go to that, and we now have the wave generator controls. We can turn the thing on and off. You've got the wave types, you've got frequencies, amplitudes, offset, pulse width in this case. It depends on what you're doing. This is pulse. So if I go to say a nice sine wave, say 25 megahertz sine wave. So now we've got 25 megahertz sine wave configured. Is it doing it? I don't know. We could find out. Settings, sync out, high voltage protection, output low, so you can actually set it to 50 ohms or high Z on the output. Zero adjustment, default settings, stuff like that. So, and system, there's information about the actual unit which is plugged into it, which is obviously this thing here. Alright, so it tells us what it is. It's hardware version, firmware version, and if you want to do a firmware update on this device, if you've got one of these and you update it to work with this particular scope, at the moment I'm not quite sure about this, but I did read this somewhere, that if you update the firmware on this to work with this scope, it won't work with your other scopes which you may normally use it with, until maybe they get updated in the future. I think the firmware currently isn't available to match. I'm not quite sure. I'm sure it'll get aligned in time and it'll work between all of them as you would expect it to. But I think if you do have one of these, be careful about updating it, because if you update it to work with this scope, you may lose the ability to use it on the other scope. You just need to confirm that with, say, Rob on the EV blog forum, for example. He'll be able to tell you, or others will. There's plenty of other people playing with these things. Okay, so that's the wave gen stuff. Obviously we can turn the thing on and off. Close that window. Turn it on. Little click came out of it. That's now putting a signal. And if I had the scope hooked up to this or a cable hooked up to this, we'd be able to see it. Display options, well, menu I already briefly showed you before when adjusted the brightness stuff. You got embedded and floating menu style. Floating will overlay it. Embedded shifts it all over. Right, so if I touch up here, it's hidden it again, and it's expanded back out, and it compresses it when it pops up. If you do floating, it'll overlay it over the top of it. Alright, so now it's cutting off that side of the waveform. So this doesn't compress. Depends on what you want to do. I prefer the embedded myself. And we'll look at this other stuff, access labels. So you have labels down the side which tells you what these levels actually are, which is really nice. You see the levels down the side there like that. So if you've got something at a particular level, instead of counting them all up and trying to calculate in your head, 6.38 is what that level there is in that graphical. Very nice. and you can also choose where they go. So if you want them in the middle instead, or on the right hand side, you can do that too. To me, I think the right hand side looks better. You've also got moving and fixed. Oh yeah, okay, right, that's what it is. So when it's fixed, the reticle stays in the same place like you'd traditionally get, and you're shifting the reference waveform up and down. In this case, when you move up and down, the whole thing moves. So you're shifting the whole reticle up and down. Windows setting, font size, and font size large. Okay, this makes everything bigger, so if your eyesight's not the best, it may help you. But obviously you lose some real estate on the screen. And you have hide menu after a certain period of time as well, so if you want your menus to disappear after you've used them instead of staying present, it will automatically hide it after a certain period of time. Okay, also got grid types as well, and clear display if you're doing like single samples, and you can do a clear and wipe it ready for the next sample for a single sample. Acquisition menu, just go in there, menu, normal acquisition and peak detect, memory management automatic, or you can do fixed sample rates, which means you can choose the sample rate you want. Right now it's got 2 gig samples a second, we can see that. If I turn on some more channels, and let's look at that again. Now down to 1 gig sample per second, as I was saying before. Do another channel, 500 megasamples, all 4 channels, still 500 megasamples. And if I turn off, say, channel 2 and channel 4, right, so using channel 1 and channel 3, that should be 1 gigasample again. It might have scaled down itself and gone down. 1G, 1 gigasample, there we go. So that's the most it will do if you do that combination instead. Turn that back off. It's a shame it doesn't automatically go up to the maximum, but maybe if you do automatic, it'll automatically use the maximum available, or as required. I don't know. Max memory depth 50 meg in this case with a single channel. If I turn on some more channels, so that's all the channels on. We'll look at this memory depth again. Now it's 10 meg max memory depth. Also got XY mode in there as well. Zoom function, so you can have a large view here of your waveform and a nice zoomed in section here. So if you want to increase your time base to get a bigger view, you can do that. Or if you zoom out, you can see the representation here of how much of your waveform you're seeing in this bottom box here. That's been around for a while, that one. It's not exactly new. But roll mode, clear sweeps, run, stop, auto setup, default setup. Auto setup, we'll just choose something. So we're not going to do that right now. Default setup, we go back to whatever setup you've designed as a default. It could be a factory default setup, which is like it's on power up most of the time, or you can save your own default setup and that's what it will use. Trigger menu. So auto, single, normal and force trigger. There's the actual menu here. You can choose which channel you're using, what kind of triggering. We've got all these different types in here. Alright, so familiarise yourself with those, have a look. You can also do digital channels, or AC9 triggering as well. Rising, falling edge, that sort of stuff. Hold off, which is really useful sometimes. DC coupling, or obviously AC coupling, and noise rejection. Noise rejection, turn that on. Didn't give you an option about which type though. Cursors, X, Y, X and Y. So if you want to do cursor measurements for a waveform, so let's just, for example, hook this up to the sample port, and we'll zoom this in a bit. Change the time base, give it more vertical resolution as well. So if you wanted to do cursors on this, you could do X and Y if you wanted to, and then you could adjust them to suit. So you see it's got this cursor here, we'll put that to the start of the waveform, right, which is there. Right, see it's changing. Push the button, you go to the, like there, to get the pulse width, or you can come over here for example and get the whole cycle. So one waveform, and then you can push it again, shift the whole pair around if you want, push it again, and you can do the vertical. So that's top one, and I'll bring it down here. This acceleration is feeling quite good actually. Yeah, that's quite good. That's actually very responsive, that's nice. I've had other scopes where that isn't quite so good. Okay, that gives you then your cursor measurements, so it gives you your cycle time, like one waveform cycle time. So you've got delta Y of 3.02, you've got delta X of 1 millisecond basically. Obviously it turns out whether you place the cursors, a use of cursors. You can also do this independently if you just want only the X or only the Y, you can do that. You also have the menu, where you can do manual cursors, tracking cursors, so it automatically changes with it. Right, it measures, you know, you set up and it automatically figures out where you might want to sample. It changes with it, that's nice. Don't be seeing that before. But I don't tend to use cursors myself. Very rarely do I use cursors. And you got measure as well. Measure item. No, I don't know how to use this bit yet. No idea. Anyway, like I said, I don't use cursors. So turn them back off. Measure menu. So I've got simple and advanced measurements. Simple measurements is what this is. It's just basic measurements, a whole bunch of default stuff. You can choose which one you want to use. When you go into this menu, you got more options. Like you do simple, you can choose which channel you're on. Source channel 1, or channel 2, or 3, or whatever. Right, if they're turned on, you can select them. So if I turn on channel 2, then I'll be able to choose that back in the measure again. And simple, channel source. Now I can choose channel 2. But you can only choose one channel at a time, you can't choose multiple channels. I think on some scopes you can do multiple channels. I think on my 2000X Plus I think I can, although I tend to do advanced measurements and do my own setup that way instead of doing simple measurements. Simple measurements are handy though, because you can just quickly pop it up, there you go, everything, or the most common measurements you might want to look at. In this case I'm going to put back on channel 1. You also have zoom, so you want to look at your zoom measurements, math measurements, and reference. Types, you can choose which types you want in here. So let's do peak to peak and RMS, and maybe we want to do min and max as well. That's vertical ones. You also could do horizontal ones, and there they are across the bottom there. If you want to go in as well, if you want to do some horizontal ones, you could do rise time, maybe full time, maybe you want frequency. Close it off again. And now we've got those as well. But the advanced one is different again. You get a few more things in here. Again, you can only go from one channel, I think. Let's turn on another channel. I can only do it on one channel. You can't do it on two channels. You only do measurements on one channel at a time. Yeah, that's a limitation. So, yep, it's got lots of measurements in here. And here you can do channel delay between channels this way. It's the only way to do reference channels, I think. Right. Okay. But that's measurements. There's lots of stuff in there. I'm sure there's something that you can use plenty of. We've also got result style embedded on floating. So floating will put it over the top of graphical. That may suit you, but in this case, as you can see, it's overlapping the graphical markings, which may not really be good. I always prefer the embedded option myself because it reserves space on screen for it. Also got config options in here. Amplitude strategy, auto and manual, which means you can choose histogram if you want histogram, and maximum, interesting, and gating as well. You can turn gating on and off. Again, that's not something I've actually used. I'm not sure I've seen that before either, actually. I'm not sure, maybe. Analysis, that's where it starts to get a bit more complicated. Search, so you can copy from trigger, copy to trigger, setup menu here. You can choose what you're actually trying to use, your configuration for that. Navigate your samples. You can do it for a certain period of time. This is like history measurement, alright, it's doing history. So there's your history option there. Turn it on, you've got a number of frames. You can do a list mode if you want list mode. There's all the samples there. You can do single steps or continuous, acquisition time or delta time. There's lots of stuff in here which I don't use myself. Decoding. Well, we can choose a bus to decode now. So because you've got 4 channels, you don't actually have to use a logic analyzer to do decoding. You can use the analog channels. In fact, if you've only got 2 channels, you can do this. For things like I2C, you can do 2-channel decoding on that. One for SDA, one for SCL. You can do that. If you want to decode SPI, then you need 4 channels. Bus operation, turn it on, and there's a decoding information on the bottom here. We're not doing decoding anything right now, but maybe I'll do something and set something up, I'm not quite sure yet. So we've got I2C, SPI, UART, CAN and LIN. I believe this has got a couple less than my 2000X Plus. Is it FlexRay and yeah, something else missing. Most people won't use all these protocols anyway. CAN bus, you may use that, maybe. UART, SPI and I2C, you're almost guaranteed to use them. LIN, I don't even know what that is. I've never used it. Don't know, never had to. So there's other protocols there which are missing, but they're ones which aren't so common. decoding signals. You can choose which channel is doing which particular winding, set your levels, protocol config. You can include rewrite bit or not, which does your decoding if your hex value or whatever value you're reading out is relevant to what you're trying to see. Bus display, you can do binary, decimal, hex and ASCII. Bus position, you can change where it is as well. It's down along the bottom of the screen here, but you can move it around. If you want it somewhere else, you can do that. And there are multiple buses. You've got 2 buses in this particular unit, so you can set up one bus for say I2C, set up another bus for SPI, and you can switch between them to do what you want to do. Or potentially you can decode 2 buses at once. I think it can probably do that if you've got 2 I2C buses. If you have a pair of I2C buses, you could put one bus here, one bus here, maybe decode them both at the same time. I'm guessing you could do that. I expect it could do that. Result list, you can also do a list on it. So result list, it will actually display in the list here all the data that's found. So if you've got a large packet, not only will it display across screen on the sample here, and you also get a list which you can then scroll up and down. You can choose how many lines you want to display and that sort of stuff. And scrolling, and you can even save the list if you choose to. Very handy to have decoding on these scopes. It's invaluable. I've used it many times. Mask test, so if you have like a sample waveform, you can choose to have a masking, so it will give an error if it's outside of that tolerance. That's something some people use. It's not something I've used. Bode plot, we can do that because we've got a signal generator here. Also, you need to configure this correctly for that. You haven't looked at any physical buttons yet. Just on screen. This is all stuff you can do remotely too. The power analysis is built in here as well. That's not something I've actually used. It's an option on this particular one, and it's doing something. It's thinking. Here we go. It's loading up. So in here we've got power quality, current harmonics, inrush current, which is a useful one. I've used that myself. Switching loss, all these other options here for doing different tests. Test state on off, input setup. So you want to configure how you got this thing configured. Tells you how to connect it all up. Instructions. Do it that way. A little bit of a guide in how to do it. Depending on what kind of configuration you're using. Measuring voltage or current or power. And counter. Let's just reset this. So you've got the counter here. Also got a counter over here. I think this one's a software counter. This one's a hardware counter. Change which channel it's on. I think we can. If you had other channels turned on, we'd use those if you wanted to. You can measure frequency, periods, or totalize it as well. This is obviously just only going to measure frequency, but if you're using this, you can do these other functions as well, which can be useful. And we've got statistics, so if you want to use those, it gives you averages and things like that for the frequency you're trying to measure or whatever you're doing on it. And that was a lot of talking, and we haven't even done the hardware buttons yet. So we've got this general purpose button here, which adjusts all sorts of things, whatever you happen to leave it on last. In this case, it's doing intensity, and this is velocity controlled as well, and this is actually working very well. I've done other tests on other scopes, including my own ones, with this velocity control, and some of them really terrible. And this one's actually working nicely. It's really responsive, and it does accelerate very nicely too. So if you turn it a bit faster, it accelerates really smoothly. That's quite nice. That's working well. There's also a push button, so if you're trying to select something, you can do that. If you push it, in this case, it goes to the default 50% intensity. Depends on what you use it on last. Cursor button, which is the same thing as we've got for the menus here. We turn those on and off. Measurement button, again, same thing for the menu. You can turn it on and off. So if you want to hide everything, you can do that. Aquire menu, again, same thing from that. Exactly the same. This brings that menu up. Display and persistence menu. We looked at all these menu options already. Persistence is up here. Alright, and got colour gradient. Oh, sorry, I missed those ones before. How did I miss those? Doing that same menu. So I've also got vectors and dots, so you're trying to see samples. If I go horizontal on this and bring it right out, you might be able to see dots. There we go, there's dots instead of vectors. If I bring that back on again, go back to vectors. We've got colour grading as well. So if you've got repeated waveforms, it will do colour grading and give you like a hot spot of where the actual waveform is sitting. That can be useful. Turn a bit off. Persistence, different persistence levels, 1 second persistence. It will, if you have a varying waveform, then you'll see a difference there. See that? So if I do that again, but with say 5 seconds of persistence or 10 seconds persistence, take this off, it'll sit there for a while. So if you've got something which is very erratic, if you use persistence, you can see it. Much like you could do an analog scope, and this will just sit there for whatever long you set it for, and then it will gradually drop off. So that's really handy if you've got something which is an intermittent issue. You can see it with that. Quick action menu, so you can choose different things from that quick action menu. You've got a save menu, so if I want to do a save that, it wants to put it onto the flash drive. See that? Flash drive is not detected. We don't have one there. Because the default was to save it onto the flash drive. Clear sweeps, that just wipes it. So if we had persistence like we do, we could do that. It will clear it, ready to go, ready for another sample. So if you've got persistence on there, you're trying to use that, but it's getting a bit cluttered, you can push that or wipe it. Decoding, which we already looked at in the other menu. Okay. Touch, so if you want to do the screen and touch it and poke at things and maybe wipe the dust off it because you've been sitting on your shelf for a little while and you haven't used it for a couple of weeks and it's a bit dusty, you can turn the touch off so you can give it a clean. Then you can turn it back on again. Default options, this has got a default setup which you can control. I think there's a setting in this one. I know the other scopes I've got have got a option there to choose what the default button does. Auto setup will do that exactly. Press continue auto setup. You get the option of cancelling and changing your mind. It's going to do auto setup on that waveform. There we go, done. You've got run stop as well, so you want to stop sampling, you can do that. Trigger buttons. Trigger setup, so you can choose which source you've got. This is stuff from up here as well, exactly the same as this menu. So it is basically that menu there. You can do it from there. The auto trigger, normal trigger, single trigger. So this will change depending on your samples, right? So if you do normal trigger, each time it gets a new sample or senses a new trigger, it will take another sample. If you take it away, it will stay there. On auto mode, it will clear it because it's constantly triggering automatically all the time. So take it off. You've got persistence still there, but let's just take the persistence off so we can see what's going a bit better. Right, so there's the waveform. Take it off. Right, it's instant. If I do normal triggering, put it on there, it's got a sample, and I take it off, it's still there. It holds on to it. It's like halfway between auto and single. If we do a single sample, it will take a sample, stop. See the run mode stopped. If I do another single, it will be nothing there. It's waiting, so this is ready up there. Stick it on there, there's a sample, first thing it grabbed. As I was hooking it on, so there's a bit of ringing going on there. And you also got level here, so you push this, it will put it as 50%, and you can change the trigger level up and down. Right, so I've got 1 volt there, push it, jumps up to halfway. 1.49 because it sensed the actual height of the waveform and it sticks it in the middle. Same for positions here, for horizontal and vertical. You can push those and put it to the center position. Okay, in both of those, and also you can adjust them where you want to put them as well, like this. There's a zoom button, which we looked at before in the menus. You want to zoom into a particular part of the waveform, look at it more closely, such as the rising edge. Roll mode, so I'm still in power analysis function apparently. Turn it off. Roll mode, when you turn this on it does roll. Okay, so if we're just doing samples, you can see that there. Alright, so there you go. So you've got things you want to look at like that, you can do that. Reference and math buttons. So reference, if you've got a reference waveform, you can save it or load it depending on what you're doing. Math functions, you've got 4 functions. Let's look at function 1, operation, turn that on. You can do 1 plus 1 or whatever you want to do. There's all these calculations you can do here for sources. You can add a second source if you've got multiple sources running, and you can do like division and all sorts of things like that. Okay, well, half off the screen here. And frequency analysis, so we can do FFT in here. Let's have a quick look at that. And we've got filters, algebraic functions, formula editor as well, so you can actually create your own ones. Not quite sure what the limits are on that. If you want to do averaging, it can also be useful to clean up noise. We've got noisy signal. There's the FFT for this particular waveform. This is starting to get awfully messy, this display, so I think we need to do some tidying up here. Also got the individual channel buttons. So channel 1 does the same thing as tapping on a screen over here. You can set your scale manually on here instead of using these controls if you want. You can zero it just by tapping that, same as pushing this. You can also copy configurations to another channel. If you want to tap on that plus there, you can turn channels on and off, or types of information. You know, you could turn a zoom on, maybe zoom 1. You can turn zoom 1 on, and there you go. And you also got the options for that particular configuration as well in there. I think I've covered everything. I've got these navigate buttons here as well. I've got these ones. History buttons, I don't tend to use these. I have used them if you're doing digital decoding. Decoding can be useful, grabbing individual packets. And also on a basic channel setup, you've got things like coupling, AC/DC coupling, you've got bandwidth limit 4 or 20 megahertz, probe types. You can set your own probe attenuation, probe check, labels. You want to call it something different, you can do that. And you also apply it to different channels. You can use volts and amps, labeling, de-skewing. So if you have 2 channels you want to try and sample something which you want them to align, and maybe the sources aren't aligned, but you want to align them so you can do comparisons. For example, you can do de-skewing here and actually make them, say, 2 channels line up together, so then you can do direct comparisons. That's useful. Inversion, you can also hide the traces. Sometimes you want to have a trace present for doing mathematical calculations or something like that, or FFT, but you don't want it to be seen, so you just want to hide it, but still have it functional so it can be used for referencing other things. So let's plug the logic analyzer in. Let's plug this cable in. Digital channels. Now it's just booting it up. It's all crammed together at the top of the screen right now, so let's see if we can do something to make this appear better, because there's 16 channels all crammed together, and you also got decoding down here as well. So you've got labels here, data address or custom, you've got levels, so it should be expecting TTL, CMOS and these other ones here, low voltage CMOS, 2.5 and 3.3 volts or custom settings, so 0 to 7 data and 8 to 15 data. Channels, you can choose which data channels you want to actually have on screen. You can turn off blocks of them, so if I want to turn off the second block, for example, I could do that. That hides the second block and expands them all. Why they only take up half the screen, I'm not sure yet. There may be a way of changing that. It seems awfully wasteful to have more crammed into that part of the screen. Digital system, so this is also for this unit, so the SLA1016 tells you about it there. Upgrades as well, do all that in there. And remove device obviously disconnects it from the scope. I'm not sure I like this spacing. I'm not sure I can do anything about that either. Changing the vertical with that doesn't help. Changing this changes which one's selected. Maybe I can move them individually. That's moving, doing this is moving that up and down. By using this knob here, you can see I'm changing the bit of that data. So if you need it to be in a different sequence because you've got it connecting up differently, you can resequence it. And you can use this dial to change which one's selected. But that's not allowing me to do the thing I want to do, which is to expand it on the screen. Yeah, I've got the data display down here. Bus position, that's only that data there. So I can't blow this up. Now this is a complaint I had a long time ago when I was doing a review on another Siglent scope, is that this data was so compressed on screen, it was really hard to actually read it. Now you got all this real estate on the screen, it could be twice as high. Obviously if you've got 16 channels, that would still be the same height, but you could keep that this ratio and add the other 8 channels on below it. Be much more visual. Right now if you have all 16 channels turned on, it's compressing it into the same space, so this bottom bit here is not so effective. Bus 2 on, there's a second decoding option there for those, so turn that off as well. It just seems a bit weird to me that I can't blow it up on screen and make it bigger. I really thought that should be something you can do, is make them further apart if you really wanted to. Now a good example of this, if you're trying to do something like I2C decoding, you're only using 2 channels. So you could have a whole bunch of these turned off, only be using 2, and it'll be crammed in. Now if I turn some of these off, maybe it will blow up some more. Let's try that, shall we? Channels go in here. Let's turn off 7. Yeah, it is actually expanding, so it is actually doing something automatically there. It is indeed shrinking and growing to the space. So if I now hide that, and I've got 2 channels further apart, so that's better. That is an improvement. It didn't used to do that, so they have done some work on this. Originally it stayed the same size and it was all compressed, so that was definitely an improvement. Yeah, okay, I think we need to hook this up to something and actually do some testing. Right, so I've hooked up a test board. Let's just plug this in, power it up, use the USB port on the front to do that. We now have some data coming in. Just trying to zoom in a bit so we get some data here. There we go. That's just counting up. So if we go to the bus, we'll turn the buses on. Bus, let's do bus 1, display it on, and down here we can see binary data going past. Data. Okay, it's looking at all those. So we could probably just tell it which ones we actually want. I'm not liking this actually. Reset data. Data width, let's go 8. Let's do 8-bit. Binary, decimal, unsigned decimal, and hex. So you can actually do decoding on that particular data in that parallel bus. If you wanted to do decoding, can we do that? Bus 1. There's no triggering set, so I haven't got a triggering set. Triggering. Can I do triggering off digital channel? Digital channel, yes I can. Digital 0. Now we have triggering. Is that the best one to triggering from? I'm not sure it is. Source D7 instead, is that better? That might be better. Is D7 actually doing anything? Maybe I'll do D6 instead then. There you go, it's D6. Data 7 is got nothing on it, interestingly. So you can see the individual bits changing up and down as it's counting. So I push decode, alright, decode menu, SCL is on D0, SDA is also D0. You need to change that when it catches up. Why can't I change that? I just crashed it. Oh, I think I just crashed it. Uh-oh. Oh, it's doing something. I did click. Can I come back out of here? Yeah, it seems to have frozen up. I said another click. It's thinking about doing something. Another click. I think I found a bug. So I just rebooted it. I'll just try going straight into decode as it doesn't show up the bus on there. Well, even though it did kind of come up. Let's do this again. Bus display, X, yeah. Protocol signals. There's no digital channels option there. So turn digital on. Then decoding. Protocol signals. Digital D1. This time it didn't crash. Okay. NTP server sync failed. Oh, okay, so I was trying to connect to the network and do that. That's great. So triggering's currently on the wrong thing. I want it to be on digital channel. I want it on clock, which is on 0. There we go. So there's some triggering. We've got some data there, but nothing that makes sense right now. Let's do an ASCII format. It's all saying negative numbers, which is interesting. I'm set to I2C, yeah, so that should be doing it, I think. This isn't really making much sense. I don't think this is decoding correctly. Triggering off D0, yeah, rising edge. Should it be falling edge? Because it's idle high. I'm not quite sure why I can't do that. I don't actually have any data here. Why has data 1 got nothing on it? This is interesting. Data on here has got nothing coming out. Well, I'm getting an interesting thing here. So on the logic analyzer input here, I'm using input 1 and input 2. But this is saying it's on input 0 and input 1. That's not quite right, is it? And here you can see it's decoding. Bus display, ASCII, yeah, that's right. Bus position, let's move this up a bit. There we go, here's the decoding. And digital decoding, bus, data format decimal, data format unsigned decimal. So I've got this discrepancy here between data 0 and data 1 and what the probe is saying. I'll show you. Here's the probe here. This is channel 0. There's channel 1. Channel 2. These have little colour bands on them to denote them. So there's channel 1. There's channel 2 because it's got red. This has got black on it. It's channel 0. This doesn't match. That's curious. Now remember when we did that 8-channel connection where it's basically doing a counter? Data 7 was always empty. Remember that? So it's almost like all 8 bits were shifted up by 1. So 1 is 0. 0 is not there. 7 is not there either because it's been shifted up. So 7 is probably bit number 8 of the next bus. So I think there's a firmware issue here with this. This is not actually numbered correctly. Somewhere in the firmware they've got 0 as 1, not 0 as 0. Because 0 is a number, believe it or not. As for getting that crash when I came in here before, that hasn't reproduced itself and I changed it to 1. So that hasn't happened again. That's interesting, it's on bus 1. If I do bus 2, bus 2. Come on. Takes a while to switch over. We'll do this again. Bus 2. Do exactly the same settings. 0 and 0. We'll tap that. Okay, it didn't crash that time either. D1 on bus 2. Okay. Bus display in hex. Bus position. We'll move it down so we can see which one it is. Should be both displaying the same data because I'm using 2 buses and it's decoding both at the same time. And it is. So, interesting though, it's gone from bus 1 is still there and it's gone to hex. Whereas before I had ASCII. So I changed bus 2 to ASCII. Now bus 1 and bus 2 are both ASCII. So if you're trying to decode with 2 buses using ASCII or some other format, or maybe binary and hex or whatever you want to do, although you've got 2 buses, both buses are going to be exactly the same because it's mirroring the setting. If we go back, bus 2 is on, bus 1 is on, that's on ASCII, bus display, let's go to hex, bus 1 and bus 2 are now both the same again, both on hex. Not a bug. Now if I do it from the decode menu over here instead, and I choose bus 1 and bus 2 and change which one I'm using, if I change between them, it changes here as well, right? So bus 1 is set up and enabled in hex. If I do bus 2 over here, even though it's disabled, it's now in ASCII. Now I'll turn it on, we've got both buses. This is in ASCII and bus 2. Go to bus 1. It's also in ASCII. Change it to hex. You've got something different now. You wouldn't go. That stayed in ASCII. That's ASCII on bus 2. Go to bus 1. Now it's in hex. But we still have 2 displays. And displays in hex. There's something weird going on here. So I'm just thinking about this data 0 being data 1 instead. This actually makes me think, I'm pretty sure I came across this before when I was doing another review. Long time ago now. Years ago. I think I saw this on another scope. Does this mean it's never been fixed? Or is it something which has recurred? Because I've noticed on my other scope, like my SDS814X Plus, for example, I've noticed that problem there. That's worked fine. I haven't had any issues with that. But then I've been using the analog inputs to do decoding, not the digital inputs. So maybe that's the issue. It's purely the digital system which is causing this problem. I think so. I'm still trying to figure out what's going on with this bus thing. So bus 1 is currently turned off. Bus 2 is turned on. When I switch between the 2, on the selection, it's changing between ASCII and hex. So bus 2 is set to ASCII, and it's turned on. If I go to bus 1, which is turned off, it hides it for a second, it comes back, and now it's in hex, even though it's turned off. So if I turn this on, now we've got both buses showing up in hex. So if I go to bus 2, because I tapped it in one place, bus 2, turn off bus 2, so now bus 1 is on instead. Give it a second, and now it's in ASCII, which is what bus 2's got, even though it's turned off. Go to bus 1, which is on, it thinks about it for a second, comes up in hex, which is what bus 1 is configured for. So it looks like whichever bus you're viewing the menu for is changing the decoding setup, even if it's not turned on. So it's like a bit of a crossover there between the 2. You can only do 1 decoding bus, not 2. So yep, that's a bug. Alright, so now I've just changed to analog channels instead. So I've hooked the analog channels up. So they're doing between channel 1 and channel 2, channel 1 being clock, channel 2 being data. You can see we've got 2 packets on screen here. Alright, so I'll zoom in slightly more. This is jumping around a little bit, which is a little bit interesting. I've probably got some kind of configuration thing here, not quite right. Or it could be the unit itself is doing some weird stuff, which is also possible. Like the test board I'm using for generate these signals. So let's do decoding on the analog channels instead. So decoding, we're going to do bus 1 again, I2C, just like before. ASCII format, yep, that's all the same. As you can see, there's nothing there right now. Protocol signals, channel 1 is clock, channel 2 should be data, not channel 1. There we go, we're seeing the results starting here. So there we go. So that is working on this one. Alright, so go up to decoding. So we've got bus 1 here. Let's zoom in again. So you got the decoding data there. So bus 2. That's still in ASCII right now. We'll turn it on. Bus display is ASCII as well. Let's make that one hex. And there's nothing there because these are wrong again. So let's go 2 on that one. So we should have 2 lots of decoding on the same channels. This threshold is wrong, that needs to come up a bit. There we go, they're now both decoding. Now this is working correctly. So on this one, this is actually doing ASCII and hex. So in the analog mode, it works correctly. Analog works correctly, digital messes up. That's interesting. Like if I do a single shot on this, just make it a bit tidier so it's not jumping everywhere. There you go, hex that line, ASCII that line. That is correct. And if I zoom in a bit more, because you're going to be querying why it said D equals, because that's what it is, D for data and then equals, then it's got the data there. Alright, so that's completely normal. So that's working correctly with analog inputs for decoding, but digital decoding is not quite right. You've only got one bus. So let's do some more testing on this. I've now got this hooked up to my RF signal generator. Obviously I don't have a 50 ohm input, but I am using the scope probe. Got it set to times 10, which means it should be doing 10 mega ohm, and the signal generator is putting out half a volt. Let's look at some measurements on here. Measurements. So because we don't actually have a 50 ohm load on here, we are measuring differently. If I go to times 1, it's going to jump it all up massively high, okay, but times 10. Let's just lower this down slightly, eh? Bring it down a little bit. So we're getting 1.02 volts at 1 megahertz. Let's do 10 megahertz, 1.04, that's fine. Stretch that a bit more. But we'll come back to 10 megahertz. Actually, I've got another test I'm on doing this. 50 megahertz, yes, 0.982 at 50 megahertz. Let's do 80, 914, 100, 924, still doing really well. 120, 885, 150. We don't have a 50 ohm load on the end. 180 megahertz. That's now 530. It's dropped a lot. So 145 is really close. 146. Okay, 145 megahertz. Based on using a scope probe for this input, I would say 145 megahertz is the bandwidth on channel 1 at least. You expect all the channels to be very similar, so there might be a bit of variation between them, but 145 megahertz for the 3 dB point, that seems fine for 100 megahertz scope. Through the scope probe, this is a 100 megahertz probe as well. Now we can do the same thing using a BNC cable and a through terminator and see what we get. And in case you're wondering how I did this, I've got one of these adapters which plug onto into the probe, which allows you to plug into a BNC connector. So I've hooked up a cable. I'm just looking to see if I can configure this to get a nice reading on screen. And one thing this doesn't have, which some other Siglent scopes do have, is a 50 ohm setting in the input menu. Now obviously, as I said at the very opening, there is no 50 ohm input resistor. There is nothing on the inputs. But some pieces of equipment will allow you to set 50 ohms in the menu here, even though it's not actually doing 50 ohms, so I can apply the calculations to the measured values. So you could say, oh, it's doing 50 ohms, actually it's not, but it will then affect the reading you get here to give you a virtual correction. Right now I'm going straight in through a terminator, I'm putting in 500 millivolts, and that's what I'm getting right now, 4 out of 8. Now I can't do 1 volt on my generator here, just can't do it. I'm using an RF signal generator for this, so I can't do that level. I mean, I could use my other equipment, but I know this is very flat output, so I want to use this. So I'm actually going to artificially skew this. It's set to 1 times. I'm going to change this. 2 to 1 is going to double the voltage. I'll adjust this to get 1 volt here. Obviously this is not real, it's fake, but it's a relative measurement, so it doesn't matter. I'm going to get this to get 1 volt, so then we can see what the 707 is using a terminator on this end with a BNC cable. So let's just adjust the IF level here very slightly. So there's 1 volt. So let's now go up in frequency and obviously comparatively see what it comes out like. Let's do 10 megahertz first, like I did before. Here's 10 megahertz. I can actually bring this up slightly, make it look a bit bigger. So still 1 volt there. Let's do 50 megahertz. Increase the time base, so we've got some relative things going on there. It's 981, 80 megahertz, 914, 100, 886, 120, 810, 140, 759, 45, which is what we got before with the scope probe, 756. So you can see here at 145 the scope probe was dropping it down to 707. So now we're actually 50 millivolts better than that, because I'm using a BNC cable, which also has its own losses, but not so significant as a scope probe, it would seem, at this frequency. So 150 megahertz, yeah, 180, that's too far down. 165, yeah, okay. So 162 megahertz is basically the top end using a BNC cable for the 3 dB point. So that seems fine. That's certainly exceeding the 100 megahertz rating of these things. That just goes to show that the 3 dB point would shift dramatically between using a scope probe, which has a 100 megahertz bandwidth on it, and a BNC cable, be gaining nearly 20 megahertz. So if you can use a cable, even better. So the next thing I'm going to do is try doing modulation on this waveform and see how we can see that on the scope. So I'm going to turn modulation on. You can see we've got something going on here. Right, so there's a few things we can do to look at this. Obviously we're looking at the RF waveform, which is then being modulated by an AM carrier. This is an amplitude modulated carrier. This is why it's jittering around, jumping around a little bit. Now we could do a few things like add persistence. So we can turn persistence on, do a 1 second persistence, and then we'll start to see what represents really an analog type display. 5 seconds, again we're going to get a lot more. Now if I bring this down instead to the audio frequency range instead, bring it down here, we'll start to see the audio waveform instead. Obviously we've still got persistence on, there's the audio waveform, but now triggering is a problem. So let's turn persistence back off again. You can see we've now got an audio waveform which is 1 kilohertz with 10 megahertz running on it. Now you will notice something else as well. 10 megahertz is what I'm injecting in here, and we are very slightly off frequency here on the readout. I think there's got a 25 ppm accuracy for the internal clock on these things. Yeah, that's something to bear in mind. Well, I think that's enough of a review for now. I may come back and do some more stuff later on, who knows. I do have some time to play around with anything which may come up, but I don't know if I've given this back or not by the time you see this video. I don't know, we'll see how it goes. So we found some bugs in here with the digital decoding, which I think were present on my other scopes as well, so I don't think it's unique to this. Otherwise it works really well, it's very responsive. I do like the responsiveness of it, it's basically instant. This velocity control is really good as well now, that's much better. The scope itself seems to be a bit of a powerhouse. It does actually have a bit of grunt behind it. For this class of scope, it's actually very, very good. It has a lot of features on it which most people would want to have, and a lot more besides. I mean, there's stuff on here which I just don't use because I just don't use those things. But okay, well, check out the links down below. Thanks Rob for loaning this to me so I can have a look at this thing. If you need questions, definitely comment down below and ask your questions, and maybe I can help. Rob, who will be watching this video, he checks out my videos and keeps an eye on things, and especially when it comes to Siglent gear, he will comment and assist you wherever he can, I'm sure. So if you've got any questions, ask them down below. Rob may well be able to answer them. He knows this gear better than I do. I'm sure he can fill in a lot of gaps where there's bits that I just don't know about certain functions because I just don't use them. You know, as simple as that. It's what you use is what you know. Subscribe over there if you want to see more review videos, or want to follow up on this thing, or keep an eye on this particular video even, or maybe future videos. If I do another one, I might do a follow up on it, who knows. I've reviewed quite a lot of Siglent gear, so I do actually have a Siglent playlist which I'll link in up there, and probably down in the description as well, most likely. So go and check those out if you're interested in various bits of Siglent gear. Could be other scopes or whatever. Thanks for watching. Catch you later.